Hello children, welcome to the next part of this video. So our topic was areas related to circles. In earlier video or earlier lecture, we have studied how to find out the area of a sector, how to find out the area of a segment. Let us recall that what we have done in earlier lecture, that is area of a sector. First is area of sector is equivalent to theta divided by 360 into pi r square. We know that r is the radius of a circle and theta is the sector angle divided by 360 complete angle into pi r square is the area of a sector, means area of minor sector here. Now second one is area of a segment. Area of segment is equal to theta divided by 360 into pi r square minus r square sine theta by 2 into cos theta upon 2. We have done in earlier lecture that how to find out the area of a sector, that is theta divided by 360 into pi r square, and area of the segment, that is theta divided by 360 into pi r square minus r square sine theta by 2 cos theta by 2. Now next is how to find out the length of an arc. This one, consider third one is length of arc. Length of arc. As circular is considered to be an arc subtended by the angle at the center is 360 degree. That means when an angle subtended by an arc at the center is 360 degree, then the length of an arc is equal to the circumference of a circle. Let us draw a figure. We draw a circle here. Let this one be the center of a circle. If this arc in a circular region subtend 360 degree angle at the center, that means the figure so obtained is said to be a circle. So angle subtended by this center is equal to 360 degree, then the figure so obtained is said to be a circle. Means if or when angle at the center, when angle at the center is 360 degrees, then arc length is equal to the circumference of the circle, that is 2 pi r, and this is the arc length or circumference of the circle. When the angle is 360 degrees, then the figure so obtained is said to be a circle. So the length of the circle is equal to r length, arc length equals to 2 pi r. Now next one, when the angle at the center is 1 degrees, then arc length is equal to 1 divided by complete angle, means 360, into circumference, that is 2 pi r. This formula is used when at the center the angle is 360 degree, then the length of arc equals to 2 pi r, and when angle at the center is 1 degree, then the length of the corresponding arc is equal to 1 divided by 360 into 2 pi r. Now when the angle at the center is theta degrees in general, let this one be the radii of a circle, and we call it as OA, and this one be the second radii of the circle, call it as B. And if this minor arc subtend angle at the center is theta degrees, then what is the length of this minor arc, means length of the arc AB. So we can write here when angle at the center is theta degrees in general, then arc length is equal to theta divided by complete angle 360 degrees into 2 pi r. This one is the formula for finding the length of an arc when the angle at the center is theta degrees. But this arc is minor arc. Now the question arises here, how to find out the length of the major arc? Clearly, area of this one is the circle, and the length of the circle or the circumference of a circle is 2 pi r. We have to find out here what is the length of the major arc. We call this as point D here. So the major arc is here A, D, B. So the length of major arc is equal to arc of this semicircle or length of this complete circle or circumference of the circle minus length of the minor arc. That means we can write area of the or length of arc ADB is equal to circumference minus length of minor arc. That means we can write it as, so length of major arc is equal to arc can be written as A, D, B is equal to 2 pi r means circumference of the circle minus length of the minor arc, that is theta, divided by 360 into 2 pi r. This will be used when we have to find out the length of the major arc. Now, on the basis of these formulas, we have some textual examples related to these formulas. So let us take example number 1 from textbook exercise 12.1. Question 1 is, now let us take questions from the exercise, that is exercise 12.1. Question number 1 is, that is the radii of two circles are given 19 centimeter and 9 centimeter. Exercise 12.1, question number 1. We have two circles of radii 19 centimeter and 9 centimeter respectively. Find the radius of a circle which has circumference equal to the sum of the circumferences of two circles. Means we have here radius of two given circles. So exercise 12.1, question number 1. So we have given here the radius of two circles. R1 is 19 centimeter and R2 is 9 centimeter. And according to question, the circumference of two circles, sum of the circumferences of two circles is equal to the circumference of the other circle. So we have here R1 means radius of first circle, that equals to 19 centimeter, and other one R2 means radius of second circle, that is 9 centimeter. And according to question, the sum of the circumferences of these two circles is equal to the circumference of the third circle. But we know that the radius of the third circle, let it be R3, can be written as radius of a third circle B equals to x centimeter. So we have to find out this x centimeter. So according to question, this is according to question, circumference of the circles whose radii are given. The radius of the two circles is 19 centimeter and 9 centimeter. So according to question, the circumferences of first circle, that is 2 pi r1. Why we use r1 here? Because it is the radius of the first circle, plus 2 pi r2. This is the circumference of the second circle, is equal to the circumference of the third circle. The radius of the third circle, we put it as that equals to x centimeter. So the radius is 2 pi into x is the radius of the third circle. Now, what is common in both the two? Clearly 2 pi is common. So we take 2 pi as common as 2 pi into R1. But what is the value of R1? It is 19. 19 plus R2. The value of R2 is, it is 9, is equal to twice pi x. So what we have to find here? The value of x. Means here it is 2 pi. Cancel with this 2 pi. We get here 19 plus 9. It is 28 centimeter is equal to x. So the radius of this third circle is equal to, that is 19 plus 9 is equal to x. So radius of the third circle is equal to 28 centimeter. So this one, now this question we recapitulate is once again, R1 is given 19, R2 is given 9. We have to find out the radius of the third circle. The question was, the circumferences of the given two circles is equal to the circumference of the other third circle. So 2 pi R1 is the circumference of first circle, 2 pi R2 is the circumference of second circle, is equal to the 2 pi R circumference of the third circle. Here we get x equals to 28. So the radius of the other circle equals to 28 centimeter. Now let us take another example from the same exercise, example number 2. Question number 2 is here, exercise 12.1. The radii of a circles are, two circles are 8 centimeter and 6 centimeter respectively. Find the radius of the circle having areas equal to the sum of the areas of the given circle. Same question, but in question first, sum of the circumferences. Now in question 2, areas of the two circles is given equal to the radius area of the third circle. So here question 2 is again R1, means radius of first circle, is equal to 8 centimeter. R2 means radius of second circle is equal to 6 centimeter. And let radius of a third circle be, let radius of other circle be equals to R centimeter. We take it as R centimeter. Now the question is, sum of the areas of given circles whose radius is given is equal to the area of the other circle. Means according to question, this one, area of first circle. What is area of a first circle? Clearly pi r square. So here area of a circle is pi r1 square plus pi r2 square is equal to area of the other circle, that is pi r square. We mention r1 for the first circle, r2 for the second circle. That implies we can take pi here common, we get pi into r1 square plus r2 square is equal to pi into r square. So here pi and pi cancel, it becomes here r1 square. The value of r1 is 8. So what is r1 square? It is 8 square plus r2 is 6. It is 6 square is equal to r square. Clearly 8 square is equal to 64 plus 36 is equivalent to r square. What is 64 plus 36 here? 64 plus 36 is 100 is equal to r square, or r square is equal to 100 centimeter. Clearly we have to find out the value of r here. So 100 is the square of 10. So r square is equal to 10 square. That implies r is equal to 10 centimeter. So the radius of the third circle is equal to 10 centimeter. Now this one is the question 2. Now we take another example from the same exercise, that is question number 4. So question number 4 from the same exercise is here. Exercise 12.1, question number 4 is that is the wheel of a car or of a diameter 80 centimeter how many complete revolutions does each wheel makes in 10 minutes and when the car is traveling at a speed of 66 km per hour. So the question is, the wheel of a car, we know that wheel is in the shape of a circle and the diameter of the wheel is 80 centimeter. So we can write the diameter of a circle is equal to 80 centimeter. Here question is, question number 4, diameter is equal to 80 centimeter. So if diameter is given, therefore radius is clearly half of the diameter, that is 80 divided by 2 centimeter, that equals to 40 centimeter is the radius of the wheel. Now the question is, how many complete revolutions does each wheel make in 10 minutes? So what is the distance traveled by wheel in one revolution? Distance traveled by wheel in one revolution is equal to the circumference of the wheel, means the circumference of the circle. So distance traveled by wheel in one revolution is clearly equals to the circumference of the circle, that is 2 pi r. That implies 2, the value of pi we know that it is 20, 2 by 7 into r. R means radius. What is radius here? Radius is 40 in, so we multiply it, you get it is 44 into 40 divided by 7. When you calculate, you get 0, 4, 4, 16, 16, 1, 7, 6, 0 upon 7 centimeter is the distance traveled by the wheel in one revolution. Now the second part of this question is, that is, when the car is traveling at a speed of 66 km per hour. So distance traveled by car in 1 hour is 66 km. Distance traveled by car in 1 hour is equal to 66 km. But the unit is here is centimeter. This one is in kilometers. We can change this kilometer into centimeter. That is, it is 66. First of all, we change kilometer into meter. So it is 1000 meter. Then meter into centimeter. It is 100 centimeter. This is the distance traveled by car in 1 hour. Now clearly, what is the distance traveled by car in 1 minute? 1 hour contains 60 minutes. So the distance traveled by the car in 1 minute is 66 into 100 into 1000 into 100 divided by 60. That implies distance traveled by car in 1 minute is equal to 66 into 1000 into 100 divided by 60. Clearly this 0 and this 0 cancel, then 6 1 hour, 6 11 hour. We get the result is here 11 into 10,000 into 10 is the distance covered or traveled by the car in 1 minute is 11 into 1000 into 10 centimeter is the distance covered by the car in 1 minute. Then what is the distance covered by the car in 10 minutes? That is multiplied with 10. Now, distance traveled by car in 10 minutes is equal to 11 into this 1000 into this 10 into by 10 minutes. That equals to 11,000 into 100. Centimeter is the distance covered by this car in 10 minutes. Now what we have to find? Number of revolutions does each wheel makes in 10 minutes. We have to find out here number of revolutions. Therefore now number of revolutions is equal to the distance traveled by the car in 10 minutes, that is 11,000 into 100 divided by distance traveled by the car in one revolution, that was 1760 divided by 7 number जो भी है, that implies here we calculate this value, we get 11,000 into 100 divided by this and multiplied with this 7 whole divided by 1760. After calculating this value, we can take this 0 and 0 cancel. We get here multiplication. We can cancel out this one. It is 11,000 into 7 divided by 176. When you calculate this one, you get, we calculate this 2, 8, 16, then 2, 8, 16, cancellation with the 2, it is 2, 5, 10, then it is 1, it becomes 2, 5, 10 and 0, 0. We get here 5, 5, 0, 0 multiplied with 7 divided by 88. Clearly again cancel out this one. We get 4 or 244 or 88. Here 2, 2 or 4. Then 1 carried becomes 15. Then 2, 7 or 14. 1 carried becomes 10. 2, 5 or 10. Then it is 0. Further we calculate it here. That is, it is 2750 divided by 44 into 7. Further calculate it, you get 222 or 44, then 213 or 26, 1 it becomes 15, 2 7 or 14, 1 it becomes 5, 2 5 or 10. Then clearly when you multiple this one, you get 1375 into 7 divided by 22. The number you get here is the number of revolutions made by the wheel in 10 minutes. Now moving to the next exercise, which is now based on the areas of a sector, length of arc and area of the minor as well as the major segment of a circle. Now exercise 12.2, the exercise based on the areas of a sector, length of arc, area of minor segment as well as the major segment. Question number 1 from exercise 12.2 is, find the area of a sector of a circle with the radius 6 centimeter if angle of the sector is 60 degrees. We have here two things given. One is the radius is given and angle of a sector is given. The radius is 6 centimeter. So first of all, draw a figure of this one, or exercise 12.2, question number 1. Radius R is equal to, it is given, radius is here, that is 6 centimeter. 6 centimeter. And central angle, we generally denote it by the letter theta, is equal to 60 degrees. This one is given. We have to find out the area of the sector. We know that area of a sector is, area of sector is equal to theta divided by 360 into pi or square. So here theta is given, that is 60 degrees, and radius is given, that is 6 centimeter. So area of sector is equal to theta. The value of theta is here 60 degrees divided by complete angle, that is 360 degrees, into pi. We know that pi is 22 by 7 into r square. The value of r is here 6, means r square is 6 into 6 centimeter square, because it is area of a sector. That equals to here 61 or 60, 66 or 360. Then this 6 and this 6 cancel. We get it is 22 divided by 7 into 6. When you multiple, you get 6 to 12, that is 132 divided by 7 square centimeter is the area of the corresponding sector formed by the angle 60 degree with radius 6 centimeter. Now the second question is, next question is here, find the area of a quadrant. In earlier video we have learned about the quadrant. Quadrant is a sector when is also said to be a sector when the central angle is equal to 90 degree. Whenever you see that it is the area of a quadrant, that means the sector angle theta be equals to 90 degrees of a circle whose circumference is 22 centimeter. We have to find out area of a quadrant, and the circumference of the circle equals to 22 centimeter. If it is quadrant, that means we can write here theta equals to 90 degrees. Why we write 90 here? Because it is the quadrant. In quadrant, theta is always equal to 90 degrees. And next one is given circumference. Circumference is equal to 22 centimeter is given. From this circumference, we can find the radius of the circle. So what is the formula for circumference of a circle? It is 2 pi r. So circumference of the circle is 2 pi r is equal to 22 centimeter. Now it is 2, the value of pi is 22 by 7 into r. We have to find out this r is equal to 22 centimeter. So here we can transpose to right hand side and 22 by 7 to the right hand side. We get here r is equivalent to 22 into, when you transpose this 2 to the right hand side, it will divide it is 1 by 2, and 22 by 7, it will reciprocal there, 7 upon 22. Clearly this 22 and 22 cancels. You get r equals to 7 into 1 is 7 divided by 2 centimeter. So in this question now we have theta is equal to 90 degree, means sector angle, and radius of is equal to 7 divided by 2 centimeter. Now what we have to find? Area of the quadrant. Now area of quadrant. Area of quadrant is equal to same formula, theta divided by 360 into pi r square. So what is theta? It is clearly 90 degrees. It is 90 divided by 360 into pi 22 by 7 into r square. What is r here? It is 7 by 2. So r square can be written as 7 by 2 into 7 by 2. Then here cancellation, 0 and 0 cancel, 9 1 or 90, 9 4 or 36. Then similarly this 7 and 7 cancel. Then this 2 1 or 2 11 cancel. Now we have here it is 11 into 7 divided by 4 into 2, that is 7 into 11 is 77 divided by 8 centimeter square is the area of the corresponding quadrant of a circle. Now here in this question we have mentioned in question that we have to find out the area of a quadrant, so we can write in quadrant theta is equal to 90 degrees and circumference is given, that is 22 centimeter, and we know that the formula of the circumference is 2 pi r. Applying the formula of circumference, that is 2 pi r, we can find the value of radius, that is 7 divided by 2. Then put all the values theta and radius in the formula of quadrant, that is theta divided by 360 into pi r square, and after putting these values on this formula, you get 77 by 8 centimeter square is the area of the corresponding quadrant of a circle. Now moving to another question, that is question number 3. Now question 3 is here. The length of a minute hand of a clock is 14 centimeter. Find the area swept by the minute hand in 5 minutes. First of all, minute hand completes one revolution around this clock in 1 hour. Means in 1 hour, minute hand makes 360 degree angle of this clock. Minute hand makes the angle made by the minute hand in 1 hour is equal to 360 degrees. So we have to find out first of all angle made by the minute hand in 5 minutes. So, and the length of the minute hand, that is radius, is equal to 14 centimeter. So we write question number 3 as radius or length of minute hand is equal to 14 centimeter. And now we have to find out theta here, that is central angle. So it is minute hand, length of the minute hand, and we know that angle made by minute hand in 1 hour is equal to 360 degrees. So angle made by minute hand in 1 hour is equal to complete angle, that is 360 degrees. Now angle made by minute hand in not in 1 hour but in 1 minute is equal to 360 divided by 60. So when you calculate 0 and 0 cancel, that is 6 degrees. So angle made by minute hand in 1 hour is 360 degrees, and angle made by minute hand in 1 minute is equal to 6 degrees. But what we have to find out? We have to find out angle made by minute hand in 5 minutes. So what is angle made by? Angle made by minute hand in 5 minutes. 5 minutes is equal to 6 into 5, that equals to 30 degrees. So we have here radius, that is 14 centimeter, and angle swept by the minute hand after 5 minutes is equal to 30 degrees. Now what we have to find out? Area swept by the minute hand in 5 minutes. That means area of sector. Now area of sector is equal to theta divided by 360 into pi r square is the area of the sector as well as area swept by the minute hand in 5 minutes. That is equivalent to the value of theta after 5 minutes is 30 degrees divided by 360 into pi 22 by 7 into r. R means radius, that equals to 14, but here it is r square, so we can write 14 into 14. Then cancel out these things, this 0 and 0 cancel, 3 1 r, 3 12 r, 36. Then 7 1 r, 7, 7 2 r, 14. Then again 2 1 r, 2 6 r. Then again 2 3 r, 2 11 r. So we have here it equals to 11 into 14 divided by 3. When you multiple, you get 14 into 11. It is 40, 14 into 1, 14, 14 into 1, 14, plus 1 is 15. Divided by 3 centimeter square is the area swept by the minute hand after 5 minutes. So this is the question number 3 of exercise 12.2. Now moving to next question, that is question number 6 of the same exercise. Question number 6 is a chord of a circle of radius 15 centimeter subtends an angle 60-degree angle at the center. Find the area of the corresponding minor and major segments of a circle. We have to find out minor segment as well as major segment of a circle. This is question number 6. So question number 6, a chord of a circle of radius 14 centimeter. First of all, we draw a circle here. This one is a circle of radius 15 centimeter. The center of the circle we call it as O, and this one be OA, that is radius. It is given 15 centimeter. And this one be another radius here, OB. This is also 15 centimeter. Further, angle subtended at the center is 60 degrees. So this angle, this is sector angle, given it is 60 degrees. What we have to find? We have to find area of corresponding minor and major segments. So we know that segment is a region between chord AB here and the corresponding arc. This one is the segment here, this part. This shaded part is segment here. But this segment we call it as minor segment. This shaded part is the minor segment. What we have to find out first of all, this ACB minor segment. Clearly, this minor segment can be find out by, so area of OACB means area of the sector minus area of a triangle. What is triangle here? So it is an isosceles triangle because both the radii are equal and one angle is equal to 60 degrees. Means when the two sides of a triangle are equal and one angle is 60 degrees angle, then the triangle is said to be an equilateral triangle. So we can find this ACB area by area of OACB complete minus area of this equilateral triangle OAB. Why it is equilateral? Because two sides are equal and one angle equals to 60 degrees. So here we can write radius in question number 6. Radius equals to 15 centimeter. Then theta means sector angle is equal to 60 degrees. So we have to find out here A, C, B. So we can write this area of minor segment. So area of minor segment we name it as ACB. This is minor segment is equal to area of a sector means area of OACB is the area of a sector minus area of a triangle OAB. What is this triangle? Sorry, it is an equilateral triangle. Why? Two sides are equal and the theta is equal to here 60 degrees. So area of the sector, we know that. What is the area of the formula? Sector formula, it is theta divided by 360 into pi r square. It is theta. What is theta here? Clearly 60 divided by 360 into pi. R square means 22 by 7 into r square. What is radius here? It is 15 square. Minus this triangle is an equilateral triangle. And in class 9th you have studied that area of an equilateral triangle is square root 3 by 4 into side square. So we can write it is square root 3 by 4 into side square. What is side area? It is 15 square. That implies it is 60, 360, it is 1 by 6 into 22 by 7 into 15 square minus square root 3 by 4 into 15 square. So what is common in both the two? Clearly 15 square is common. So we can take this 15 square common. Here it is 1 by 6 or 1 by 6 into 22 by 7 minus square root of 3 by 4. Here it is 15 square is 225. Then here 1 into 22 is 22. Divided by 7 into 6 is 42. Then minus square root 3 by 4. So after simplifying this one, we get the cross multiplication, or we cancel out these things. We get here. So here it is 225. 225 into, we cancel out first of all 2 11 or 22 here, then 2 21 or 42. We get 11 divided by 21 minus square root of 3 divided by 4. That implies 22 225 into 11 into 4 is 44 minus 21 into square root 3 is 21 square root 3 divided by 4 into 1 4. It is 84 square centimeter is the area of this minor segment ACB. Thank you for this video lesson.